Alright, pre-algebra, lesson 17 is on least common multiple. Don't confuse this with greatest common factor. When you're finding the greatest common factor, you're finding the smaller numbers, the factors of each number, and finding the greatest one. Least common multiple is going to be a bigger number, but the least one that they have in common. So to find the least common multiple between 12 and 18, you can just do lists of the numbers. So list your multiples of 12. Don't say 2 and 6, 3 and 4, those are factors. Multiples of 12 mean counting by 12. So 12, 24, 36, 48, 60. Make a list of 18. 18, 36. Already we have a match. The least common multiple is 36. Another way you can do this is to find the prime factorization of each one. So 12, the prime factorization of 12 is 2 squared times 3, 4 times 3. And the prime factorization of 18 is, 2 times 9, 3 times 3, so 3 squared times 2. Once you have your prime factorization, take the numbers that have the greatest exponent, so 2 squared here, 3 squared here, and then multiply those together. 2 squared is 4, 3 squared is 9, 4 times 9 is 36. Okay, so 2 ways you can work out the answer. A word of caution, when you are doing the prime factorization method and you come out to where neither prime number has the greatest exponent, where they might have the same, you kind of just have to do a trial and error and check your answer. So either you can list your numbers or try prime factorization. So go ahead and try to find the examples on the right there and pause the video and replay it when you're ready to check, or you can rewind and look at the example again. Okay, for that first one, 6 and 9, since they were kind of small numbers, I just listed them. And I found a match with 18. Okay? For 9 and 12, this is 3 squared. And like we said before, this is 2 squared times 3. 3 squared times 2 squared. 9 times 4 equals 36. So the least common multiple between 9 and 12 would be 36. Now that last example, you've got 3 numbers. So here's where you might want to try the prime factorization, since you've got more numbers to work with, and your lists of numbers might get really, really long. But the prime factorization for 10 would be 2 and 5, 2 times 5. 15 would be 3 times 5. 20 would be 2 times 10, and then 2 times 5, so 2 squared times 5. There's my biggest exponent there. But over here and over here, the exponents are both 1. So there isn't a greater one to circle. We can just kind of try and guess. So I'm going to try the 5 over here and the 5 with the 10. So 4 times 5 times 5. 4 times 5 is 20. 20 times 5 is 100. See if we can find one smaller than that. We'll keep the 2 squared here, but then let's try the 3 and the 2. So 2 squared is 4 times the 2 here times the 3 here. So 8 times 3 is 24. We know that can't be right because 15 won't work. None of these will work. They're not or 24 is not a multiple of any of those numbers. So scratch that. Let's try, you may have 100. Let's try, instead let's try this 5. So we've got 4 times 5 times 2. 20 times 2 is 40. That doesn't work because 40 is not a multiple of 15. So we'll keep that one. Let's try the 5 over here. 4 times 5, no wait. Try the 3 and the 5. 4 times 3 times 5. 4 times 3 is 12. 12 times 5 is 60. That's less than 100, and they both will add, or 60 is a multiple of all those numbers. So 60 is our answer for that one. You could have just done lists as well. So if you have any questions about those, come back with them tomorrow. Or if you want to replay and try again, you can. But we'll talk more about it tomorrow.